So this completing the square technique for solving a quadratic equation is actually the technique that is used to prove the quadratic formula. I thought we'd just practice a couple here. When the leading coefficient is a 1, completing the square is really easy. You just have to take half of this number, half of b, and then square it. So half of 8 is 4, 4 squared is 16. Putting that 16 in that blank completes the square, because now this can be written as x plus 4, the quantity squared. For this second problem, if I take half of b, by the way, the leading coefficient is still a 1. Half of negative 16 is negative 8. Negative 8 squared is 64. Putting a 64 there completes the square. And now this can be written as x minus 8, the quantity squared. The number that goes here is just half of b, the number you get before you square half of b. So to complete the square on your problem, we have to end up adding the same number to both sides to keep the equation in balance. Half of this b, half of negative 5 looks like this. Half of negative 5 is negative 5 halves. Squared is 25 fourths. So that's the number that completes the square. 25 fourths. But if we add 25 fourths to the left side, we have to add 25 fourths to the right side. Now I'm going to erase this work down here. And what do you do from this point? Well, we can now write the left side, since it's a perfect square trinomial, as x minus 5 halves, the quantity squared. And over here we can combine these two terms into one fraction. Negative 20 is actually negative 80 fourths plus 25 fourths. That's going to be negative 55 fourths. And now what we do is use the square root property, taking the square root of both sides. So the square root of something squared is the something. The square root of negative 55 fourths, when you take the square root of a number, there's a plus or a minus. So we have to write plus or minus the square root of negative 55 in the numerator. And the reason I broke this apart is because I can see the square root of 4 is 2. So I write it that way. And now I add 5 halves to both sides. And I've got my solution. Oh, but both denominators are the same. So if I want to just write it as one fraction, I can write plus or minus the square root of negative 55 over 2, all over 2. Now, of course, this is actually an imaginary number. You cannot take the square root of a negative number in the set of real numbers. So we would write plus or minus 5 plus or minus square root of minus 1, we write with the letter I. Square root of 55 does not simplify, all over 2. There you go. That's how you solve this equation by completing the square. You get the same exact thing if you use the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This formula comes from using the complete the square technique on the equation ax squared plus bx plus c equals 0. Use complete the square to solve for x, and you will get this formula. The difference is that we don't have a leading coefficient of 1. There's an extra step involved there, which we won't talk about in this video. But there you go. Hope that helped. If you have any questions, post a comment.